So today's lesson is dealing with counting principles. We are going to focus on two concepts. We're going to take a look at a thing called tree diagrams, and we're also going to take a look at a thing called the fundamental counting principle. Okay? And we're going to look at some methods to determine the number of outcomes. So now let's take a look at what a tree diagram. Okay? Tree diagrams are useful in the sense that they can help us map out what's happening in a situation and show all the different ways to come to a conclusion. So when we look at this problem that we have here, okay, this problem is Jenny's heading out for night on the town. She has 3 pairs of shoes, 2 dresses, and 5 shades of lipsticks to choose from. Okay, determine how many options does she have for her night out. So here's what you need to understand. I'm going to highlight these things in different colors, okay? Now, in green, if you look at this, right, there are 3 mutually exclusive choices that she has. So if you think about it, she has 3 pairs of shoes. Okay. Then she has 2 dresses. And finally, she has 5 shades of lipsticks that she can choose from. Okay. Now, because she's got all those options, there are different ways to look at this. Now, we call this a tree, but really we want to call this a sideways tree. Now, Jenny, because she's heading out on the night for a night on the town, you got to understand she's got 3 different choices of things to be done. We're going to break this down into 3 separate parts. 3 separate choices. So first, she has her shoes. Then she has a choice for her dresses. And then she has a choice for her lipstick. Okay? So once we've got that, we can take this information and use it to create a sideways tree. So when she starts getting ready for the night, this is where I start here. And I say, well, for her shoes, she has 1, 2, 3 possibilities. And what we've essentially done is we've created a broken tree showing where our paths are. Now, depending on her choice of either 1, 2, or 3, she has choices for her dresses. So let's imagine she chose shoe 1, right? Now she has 1 or 2 choices for her dresses again. So she's chosen 1 or 2 choices. Now, imagine she didn't choose the first set of shoes in her first choice. She chose the second set of shoes. Well, she would still have 2 choices, 1 and 2 again. And then for 3, same thing. And what's happening here is all we're doing is we're mapping out or showing what possibilities we have for the different choices. Maybe her first shoe was blue, her second shoe was black, and her third shoe was green. And then her dresses, she had 2 dresses. She may have had a black dress, and then maybe she had a blue dress. And based on this, we had different paths we could have chosen. So now let's talk about her lipstick. With her lipstick, you know that she has 5 choices for her lipstick, which means that let's say that she followed path 1. So that would be this one right here. So she chose her lipstick, she chose her shoes, then she chose her dress, and then, hey, she's going to go choose her lipstick. And so we have 5 possible choices again. Now, for this second pot here, we're going to have 5 choices again. And we will make a tree that goes to those points. And we'll do the same thing again for the next set. And we do this ad infinitum. All the way down until we are finished. So let's go here. 1, 2, 3, 4, 5. And we'll draw that as well. Okay. And you guessed it, we still have to create another set of choices for the final branch that goes from here all the way down to here and to here. And we should have another set of things here. So let's just zoom out a little bit. And we'll draw those in. So our next set of points are going to be 1 to 5 again. And we're going to have 5 lines that go to that section. I guess I'll put 2, 3, 4, 5, and then we'll do our final set of 1, 2, 3, 4, and 5 choices. And all of those are coming down from 2 to those. So once you've gotten to this point, you need to ask yourself, how many options does Jenny have for her night out? Well, here's what would happen. You look at each one of these paths as an individual choice. So maybe she chooses her first shoe, then chooses her first dress, and then chooses her first lipstick. That's one possibility. Then maybe she goes and chooses her first shoe, first lipstick, and then, first dress, and then second lipstick. That's her second choice. And we can do this, and all it says is for that tree, there are 5. And guess what? There are 5 more possibilities. Again, 5 more possibilities, 5 more possibilities, 5 more possibilities. And when you add up all these possibilities, that will tell us the number of choices that we have or options that we have for her night out. And in this case, we would say that therefore she has a total of, well, 5 times 1, 2, 3, 4, 5, 6. 5 times 3 is 30 options for clothes. And we're done. And that's how you use your basic tree. Now, pause the video. I'm going to ask you to answer this specific question that I came up with for you. So here's what you need to know. We're going to take a look at this question here, and it says, explain how tree diagrams can be used. Well, the first thing that you need to understand is that they are made up of multiple independent effects. When you hear the concept of independent events, we're actually talking about events or choices that don't affect one another. So, for example, if I choose my shoes, that doesn't affect my choice in lipstick, like we had in our first problem set. Now, we basically use these diagrams to visualize all possibilities of our decisions. So if you think about it, right? Maybe one day you wake up and you say, I need to wear a certain set of shoes. Then you have to figure out, of your 6 pants, which ones you're going to wear for the day, right? And then you pick one of 4 shirts that you wear for the day. And you could say to yourself, how many ways could I possibly find a combination of clothes? That's it. It's not that difficult. Okay. So what I'd like you to do is I'd like you to just write down this concept here. Maybe for an example of this, you could have said looking at building a computer. You could look at, say, buying cars. etc. All those possibilities are what you could use to do this problem. So now we're going to take a look at this second topic that we were going to look at. It's called the fundamental counting principle. Here is the fundamental counting principle. So if an action can be performed in M ways, so think about the number of shoes that we had in our first problem, okay? And a second action or choice can be made in N ways, then the total choices, how about not choices, ways, M and N occur, is M times N. So let's take a look at this first problem here. Barney is choosing an apartment. Okay, now, if he has a choice of 2 types of flooring, 3 layouts, and he has another choice of any 10 floors for each model, how many apartment options are there? So here's what we're going to do. When we do this problem, I tend to lay out all the choices that I have. We have flooring, we have layouts, we have layouts, and we have choices for something else. And then we have 10 floor models. Okay. So these are 3 different independent events. So here's what we do. Ready? Flooring is 2 possibilities. Layouts is 3, and models is 10. So in order, because these are all independent or all unique, one right after the other, you'll notice that our final answer is 2 times 3 is 6 times 10 is 60 ways. 60 ways or options is what we have. Okay. So now let's move on to our example with this car. Okay. So this car comes in 5 different colors. Okay. So I'm going to immediately lay out what my points are, what my independent stuff is. So in this case, I have 5 colors. Okay. That's my first thing, right? Then we have 3 different interior colors. I'll call it the int color. And then once I've got my interior color, I've got 3 different engines. So that's my next thing. I've also got 2 different types of rims. And finally, 4 different radios for my car. So let's go and fill out all these independent things that we're using. So we've got our Colors. We've got our colors, which is 5. Our interior colors is 3. Our engines is 2. Oh, 3 engines as well. Our rims is 2 and 4 radios. So now all we have to do is we're just going to take this thing and we're going to multiply all that information together. 5 times 3 is 15, times 3 is 45, times 2 is 90, times 4 is 360. So therefore we found that you can have 360 different ways to have your core ordered. And we're done. And so all you have to do right now is just multiply all those things to get your final answer. And you just have to tell me how many ways is there. Now, let's move on to the last 2 questions. 3 questions, I believe. All right. Now, this problem here involves us thinking about all the different ways certain letters are arranged and how many letters there are and things like that, right? Okay, so let's read this. How many different 4-letter call names for radio stations can be there if the first letter must be a W or a K? In order to solve this problem, what you have to do is this. Lay out what you have to have. So I'll lay out 4 different letters for our call sign, right? So now, in the sign, we should have a W or a K. And we indicate that by writing in that spot where our W and K would be. Now, how many letters are in the alphabet? The alphabet has about 26 letters, right? So the letters from here in this second block should have A to Z, A to Z, and A to Z. So what we've essentially done is we've actually looked at all the possible numbers that would occur in each of the letters in the call sign, right? So in the first block, how many possibilities did we have? We had 2 possibilities, right? In the second block, where our first letter is, we have a choice of 26 possible letters because A through Z is a total of 26. So we write 26. So we say, so this is choose the first, and then we choose the next letter, 26. And because we're choosing it, and it's an independent event, we have to multiply it by 26. We do the same for the next one and the next one, because all of these are independently chosen. So we pick one of either W or K. Then we pick a letter from A to Z, pick another letter from A to Z, and pick another letter from A to Z, which gives us something that looks like this. 2 times 26 to the power of 3. Okay? And you will say, therefore, there are 2 times 26 to the 3 different let's call them call names. And so now we'll take a look at something very similar and very close to my heart and all of your hearts because you like to work. You know this card. You're given one of these from the moment that you are born in Canada. We have a thing called a social insurance number, right? And notice the social insurance number has 9 possible digits. Now, this problem here has asked us how many different SIN numbers can be created using the numbers from 0 to 9. Now, you'll notice that there are 9 possible numbers for there are 9 possible spaces for our social insurance number. So I'm going to do them very similar to what you would see there. So there's my first block of 3, second block of 3, and then my last block of 3. So now, when I'm looking at this problem, it says, how many different numbers can be created using them? When the numbers can be from 0 to 9 in each possible spot. So we'll just fill that out and show what our possibility. Now, the numbers from 0 to 9 total, if they're 0 to 9, if I count all those possibilities, are actually 10. There are actually 10 choices. Okay, so for position 1, there are 10 choices. And for position 2, there are another 10 choices. And for position 3, there are another 10 choices. And when we get to position 4, 10 choices. And you'll see where this goes. And when we calculate this, this gives us 10 to the 9 different ways. Therefore, there are 10 to the 9 different SIN numbers. And we're done. So now we're going to do the indirect method for the fundamental counting principle. Now, this one is all about basically working backwards. You'll see in a second. Now, let's do this problem the easiest way. So, an athlete has 4 pairs of running shoes in her gym bag. So imagine she has blue shoes, 2 blue shoes, 2 red shoes, 2 green shoes, and 2 yellow shoes. Okay? Now, an athlete has 4 pairs of things in her running bag. Determine how many ways she can pull out 2 unmatched shoes. So if I was going to do this and I had my green shoe, I pulled out my green shoe, right? And then I got the unmatched. And then I had my blue shoe and got unmatched. And then I got a yellow shoe and then unmatched. These are all like different possibilities. And then the red shoe, and then we had an unmatched. So here's what you would know. This is the scenario. And then this is the mathematical calculation. So imagine I choose my green shoe, right? So there are 2 possibilities to choose from when we start, right? Then once we have chosen that green shoe, the second thing is it says, hey man, it's got to be unmatched. So if it's unmatched, that means we got to eliminate this green shoe. How many choices do we have left? We have 1, 2, 3, 4, 5, 6 possibilities. And all of those possibilities is represented by 6. So 2 times 6 is 12. And if we do the same calculation again by drawing up our sheet, drawing up our possibilities again, and then choosing. So, all right, we have 2 blue. We choose one of them. Boom. There's 2 choices, right? And now, in order to unmatch them, there's 6 possibilities again. So it's 2 times 12. 2 times 6 is equal to 12. And then 2 times 6 again is also equal to 12. So therefore, we would add up all of these different possibilities. So therefore, there are 48 ways. Now, here's my question for you. What would have happened if I changed the 4 different pairs to, say, 12 different pairs? Then you would have had a chart that would have extended all the way out to from the left of this page to the right of this page, and all the way down, because you would have to calculate and show all of the different possibilities of you not getting a matching shoe, right? So this direct way of us finding the number of ways shoes are being constructed or found tends to get unwieldy, right? So let's go and do an indirect method for finding these shoes. So we're going to go backwards in this case. So you'll notice this one would just get ridiculously unwieldy. So let's say we had our same shoes again, right? And now we don't care what shoes comes out, and we don't care if they matched. So what we want is just choose something with no restrictions. So now the key idea is to first find all possibilities with no restriction. In other words, I don't care what two shoes I get. So if you think about it, for my first shoe and my second shoe, there are 8. And once I pulled out my first shoe, there are 7 shoes left. So now I've got 56 shoes. Okay. So here's step number 2 for finding this answer indirectly. So step 2, what we have to do is we find what we don't want. Find what we don't want. Now, what we don't want is, so we don't want, i.e. in this case, remember we said we didn't want any matched shoes, right? But in this case, instead of being unmatched, we want matched shoes. So imagine you stick your hand into your bag. You have 8 possibilities of finding a shoe, right? But then what happens is when we pull out our second shoe, we want it to be the actual matching shoe. There's only one other shoe left, right? So we have to times that by 1, and we end up with 8. Oh my goodness. And step 3, since we have our 2 possibilities, we have 56 and 8. Step 3 is all we have to do is subtract step 1 and 2. So now we have 56 minus 8, which is equal to 48 ways. Again. And that's it. So your homework right now is to work on page 229, questions number 1 to 24. It's going to take some time, so I'm going to give you this morning and this afternoon to work on it. Like I said, your homework is page 229, number 1 to 24, and it's going to take some time to make sense of this, okay? At the end of the day, I will have something for you to answer to kind of make sure that we understand what's going on. And if you have any questions, we can work through the problems throughout the morning and afternoon. Take care.